theta is 1/2, and tangent of theta is greater than 0. So this is given. And then they're asking us find cosine of theta. So this one, good. We have sine of theta is 1/2. So you see 1/2 here, also 1/2 there. This is the extra information. When they say tangent is greater than 0, so I mean this telling us that you need to pick a quadrant. Which quadrant is that? Tangent of theta is greater than 0. Tangent is positive in quadrant 1 and quadrant 3. So now what do we have? So we see sine is positive, correct, is 1/2. That means theta going to be on quadrant 1 or quadrant 2, because quadrant 1 and quadrant 2, sine is positive. Tangent is positive in quadrant 1 and quadrant 3. So now which quadrant is the theta, this theta, that holds both of them, which is sine is positive, also tangent is positive. It will be quadrant 1 because this is a double shaded, correct? So now we know our theta is in quadrant 1 and cosine of this will be radical 3/2. Does that make sense?
Yes.
So we just want this. I don't want you guys confused. Oh, what do we need to use? Why do we need to have tangents? We already can pick cosine because sine is 1/2. No, this tells us which quadrant, and this is very important. So let's have another question. The other question will be, tangent of theta equal to 1. Theta is between pi/2 and 0. So greater than 0 and less than pi/2. So this gives us little information. So given this, find sine of theta, cosine of theta, cotangent of theta, secant of theta, and cosecant of theta. So they ask find their 5 remaining. So the idea is before you just look at what is sine of theta, we need to decide which quadrant this theta is. Because there are multiple answers for tangent of theta is 1. For all of them, there are multiple answers. And we should pick only one of them that holds this condition. So we need to decide, is that here, 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 or here. So we have 0, pi/2, pi, 3 pi/2, and 2 pi. So which quadrant is that? I'm sure if I ask Edison will answer me. Is that quadrant 1, quadrant 2, quadrant 3, or quadrant 4?
Quadrant 1.
Edison? Okay. Yeah, quadrant 1. Why is that? Because here I just tell you guys theta is between 0 and pi half. So between 0 and pi half. So it has to be here. So theta is there. And the theta is, the answer of tangent is 1. On the table or unit circle, anytime you see 1, 1/2, radical 3/2, radical 3, radical 3/3, those are the number that you see it on the unit circle. That means you can just refer it to the theta. Agree? If I ask you guys, what is the value of theta? Instead of asking what is sine, what is cosine, what is cotangent, cosecant, and secant, if I ask you guys, solve for theta, what is theta?
45 degrees.
Yeah, at 45 degrees, tangent is 1. You said 45, which is great, also pi/4, correct? In homework, we have to know what they want, so that which type they want. So here is I put 45 degrees, but because I give you guys pi half, so put pi/4. So we also able to solve the theta, which is another topic in this course. But when you see a number which is you already seen, that means we know exact value. So now that we know that this is 45, so on the circle that you draw, you need to make 45. This is 45 degrees. So now what is sine of 45? Is radical 2/2. Cosine of 45, you don't need to put 45 here because when you see radical 2/2, radical 2/2, you got to put radical 2/2. Cotangent is 1. Secant and cosecant, so secant of theta is 1/cosine of theta, 1/√2/2. It will be 2/√2. You multiply by √2, you get 2√2/2, which is √2. This is √2, also this is √2. Any question here? No question? All right. I see no question. So now let's have little spicier. The spicy will be given. This is very important for this course. Given cosine of theta equal to, pick something that makes sense. 5/13, correct? And So, and tangent of theta is greater than 0, then find sine of theta, tangent of theta, cotangent of theta, secant of theta, cosecant of theta. So the same type of question. I give you one trigonometric value for theta and ask the remainder. Unfortunately, 5/13 is not, you don't see 5/13 in the unit circle, correct? It's not there. The previous two questions, we had 1 and 1/2. So it was something that you could click. So we could just refer it to any of those angles. But now we have no idea what is 5/13. So what does it mean? That means this unit circle is useless. So we cannot use it. We need to have our own. So what do? We just get rid of this. And we make a circle. Good. Then we know this is 0. That's pi half. This is pi. Here's 3 pi half. That's 2 pi. What's the first thing we should do here? What's the first thing we did in last two examples?
Figure out what quadrant.
Excellent. We need to figure out what quadrant theta is. Because we know this cosine of theta is 5/13. There are two quadrants has that value. And we cannot have two quadrant and then solve for theta. So we need to know which quadrants. And it's super important. If we miss the quadrant, whatever algebra we do is wrong. So cosine of theta is 5/13. Is this positive or negative?
Positive.
Positive, right? Is positive 5/13. So cosine is positive on quadrants. This is cosine, correct? Here is positive on quadrant 1 and positive on quadrant 4. So positive here, this is cosine. Positive here. Any theta you pick on quadrant 1, cosine of that is positive. And any value you pick on quadrant 4, cosine is positive. And then they said tangent is positive. Where tangent is positive on quadrant 1, tangent is positive, and quadrant 3, tangent is positive. So now, which quadrant this theta lies?
The first one.
Good, Karen. Whatever difficulty I make the question, you always have a smile, which is great. Makes me make it more difficult every time. So it is in quadrant 1 because it's double shaded. So we find the cosine, we find the quadrant. So I'm going to go back to this. So I randomly, I just make something like this, and I call this one theta. Not exactly theta is there. It might be here, it might be there, but I mean, because we don't know the value of theta, I randomly pick that as theta. So this is theta. This is quadrant one. And cosine of that is 5 over 13. So we need to find sine of that, correct? So so I think you guys are following me. So now I'm gonna, the next, after we find the quadrant, we need to make a right triangle. We make a right triangle. Good. So we have cosine of theta equal to 5 over 13. You have on your note sheet or somewhere in Claude, we have cosine of theta equal to x over r, correct? This is x, that's r. That means x is 5, r is 13. So I'm going to put 5 and 13. We use Pythagorean theorem to solve for the y value, this value. We have x squared plus y squared equal to r squared. We have 5 squared plus y squared equal to 13 squared. Y squared equal to 13 squared minus 5 squared. 169 minus 25, 144. Then y will be radical 144, which is 12. Okay, so this is 12. So sine of theta is y over r, which will be 12 over 13. Tangent of theta is y over x, which is 12 over 5. Cotangent is x over y, which will be 5 over 12. Secant is reciprocal of cosine is r over x, which is 13 over 5. Cosecant is r over y, which is 13 over 12. I know I solved this one before, but this is super important, super important for this course. It's like solving this type of question is, I would say, 40% of what you learn in this course. Any question here?
No question.
All right.
Also, I had to leave and rejoin because my audio cut off.
All right. So let's learn 2 new topics. All right. I'm going to go back to a circle. We have for some reason is not what I want. So this is 0. If you go this direction is plus, correct? We have pi half. We have pi. We have 3 pi half and 2 pi. We learned a sector, the arc length S equal to R multiplied by theta, correct? If I ask you guys what is like a length from here to there, for example, from A all the way to B. This arc, you connected this one. This is an initial site, correct? That's a terminal site. This is a terminal site. That's the initial site. And this makes a theta here. And if you want to find this S arc, it will be R multiplied by theta. That's what we learned. If you want to find the area of this sector, this much, correct? Formula of area equal to 1/2 R squared theta. The only important things about these two formula is that theta must be in radians. If it's not radians, then it does not gonna work. Has to be in radians. Cool. On the, for example, if there's a bike or scooter here, if somebody's doing a scooter, if you want to know what's the speed of this guy, right? How fast this going go from A to B. In physics, we learn the velocity or the speed of this person. V will be distance from here to there divided by time. That's how we find the speed of a person or the speed of the car or anything. So velocity or speed equal to distance divided by time. Now, if the person is on this curve, what is the speed? So the formula is same. Speed will be distance divided by time. The distance from A to B, because we are on the curve, this distance same as S, because S is a distance too. Agree? So there is a formula V equal to S over T. Exactly same as the physics on the linear time, on the line, correct? But on the arc, it will, instead of D, which is distance, I'm going to put S because that's how we labeled it. And what do we call this? We call this one linear speed. So the linear speed will be S over T. Any question here? So we got the new formula, the linear speed, and S over time. So I'm gonna write linear speed V equal to S over time when the person is like scooting on this arc. We have another formula here. Something, the speed of this theta. Because when the person is here, the theta is there, correct? Then the person goes there, the theta gonna be here. Then the theta getting, so this theta getting larger, 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 and stop at B, because that's, we would like to know what is the speed of that person from A to B. But this theta changes too, correct? And they call it angular speed. That means how fast this angle grows. It goes like this or goes slowly. So the speed of this theta, they call it angular speed. So one more time, so the person goes from A to B. Speed on the curve is a linear speed. This theta also changes. The speed of the change of the theta will be angular speed. And we show it with omega. Omega will be, because we are dealing with the speed, again, is the distance of theta. So it will be theta over time. And linear speed V equal to S over T. Any question for these two formula? Is this make sense? Do you see can you guys visualize it?
Where do you get time from? Like, how do you calculate the time?
Very
Is
good.
that given?
Yeah, I mean, in question like this, they give us the time, but it should make sense that this angular, correct, the speed of the angle opens, how fast this opening, also the speed on the curve. For question like this, yes, they give us the time. So we have two formula, and we are able to come up with another formula. Let's see. Look at V equal to S over T, correct? This comes from the physics, distance divided by time. This S here, we have a formula R multiplied by time, by theta. So instead of S, I'm gonna put R times theta, then divided by T. So instead of S, I put R times theta. We see theta over time, good? This is exactly the same as angular speed, omega. So instead of theta over time, I will put omega. So then V equal to R times omega. So now we got a new formula from linear speed to angular speed. So that's a new formula. Let's see if I can find the example for you guys. But in your note sheet, we have four formulas related to this topic. The first one is S over equal to R multiplied by theta. Then linear speed equal to S over time. Then we have omega angular speed equal to theta over time. Then we have another one between V and W, which V equal to R times W, correct? This much formula you have in your note sheet related to question like this. So now which one you want to pick? So we see the last one, the last homework, the last homework, the last formula here, this one. We have V is given, R is given. We're just looking for omega. So we can just solve it. You can say 10 equal to 20 multiplied by omega. So we have, so if you're gonna, then omega will be 1/2. Angular speed is 1/2. For today, I would like you guys just deal with the formula. Then some of the homework question, some of the question might be little, it gets complicated when we're dealing with this. We work on this on Monday. But for now, for today, I want you guys to know that there exists a formula like that. Any question?
Can you give us examples of the other formulas?
Sure. Other formulas?
No, like the ones that you have, like you only did one formula.
Yeah. We got.
Other-
I want you guys. I don't want to freak you guys out. This is a formula for today, correct? You know this. I would like you guys to. I mean, S. It makes sense to you guys now. This length, this arc, will be R multiplied by this. We talked about this. Now we are dealing with linear speeds. I want you guys to just visualize it. And then omega, which is angular, the theta here, what is speed of the theta. And this is a relation between linear speed and angular speed. And then we do example on Monday. Okay. There's only two or three homework questions related to this, but usually they give us enough information to solve it. All right. So let's have some of the favorite question. Identities. So the first thing for identity, we need to decide, should we start from left, go to right, or from right, we go to left? Which side should we start?
Left.
So picking which side is very important. We don't want to start with the side that doesn't have that much to do. I mean, if you start from the right side, if you start from here, it means kind of difficult to start with the little and then expand it to the other side. We try to start with the side that we can do some algebra. So we go with the left side. And the idea is we should not do any mistake to get others. If you do one small mistake, then you're not able to get to the other side. So we have already in sine and cosine. Good. So it's good. If we had tangent and cotangent, if you had like a tangent of theta, you should make that to sine theta over cosine theta. Or if you have cotangent of theta, you would make it cosine theta over sine theta, correct? And if you have sine theta over cosine theta, we don't want to make it to tangent theta. You don't want to make this one to tangent of theta. We're gonna, I mean, if you, this is tangent of theta plus, and that one is cotangent of theta. If you do this, then now it's more complicated to go to that side. All right, so if you have tangent and cotangent, you make it to these two, but we don't go reverse. So we find a common denominator, which will be cosine theta times sine theta. So I'm trying to add them. The first one missing sine theta, I have to multiply this by sine theta, sine theta. Sine theta times sine theta is sine squared theta, plus this one missing cosine of theta. I multiply by cosine theta, I get cosine squared theta equal to. What is sine squared plus cosine squared? Is 1, correct? Now, instead of this much, I can put 1 divided by cosine of theta times sine of theta. Now you look at the other side. We're almost there. I can, so 1 over this one, I can make it 1 over cosine theta times 1 over sine theta. 1 over cosine theta is secant of theta, and 1 over sine theta is cosecant of theta. So we proved it. It's like a cosecant theta times secant theta. So we are done. So finding it, the simplifying and finding common denominator is another technique for proving identities. Any question here? I means identity. Question?